welcome to Area of Quadrilaterals. Just before we begin, I just want to remind you that there is a notes jotter available for this video, so just check the description below for a download link and you can work along with me as we go through the video. Okay, so the first thing we need to just think about is what do we actually mean by area? Now, area is basically, it's the space inside of a shape, or the amount of space that a shape covers. Now, that is measured in centimetres squared, or metres squared, or millimetres squared, depending on what unit we are starting with for our length. And the reason we use centimetres square is because of each of these little squares within the shape. If this is a centimetre square grid, then each of the individuals is 1 centimetre square. So, how can we work out the area of this rectangle? Well, we could use the actual grid that we've got and just count up the squares. In this case, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And so this rectangle would have an area of 15 centimetres squared. If we did the same for the second one, if we just count up each of the squares, we've got 8 across and we've got 2 up. So we've got 1, 2, 3, 4, 5, 6, 7, 8, and then 9, 10, 11, 12, 13, 14, 15, 16. We have 16 centimetres squared. But as with lots of things in maths, there must be a much easier way or a quicker way of getting to that result. And if we have a look at the two numbers, in the original rectangle we had 5 and 3. We came out with an answer of 15. 8 and 2, we came out with an answer of 16. How could I get that number really quickly? Well, I could have done 3 times 5 or 2 times 8. So basically what I have done is I've multiplied the height by the width, and that is the formula we need. The area of a rectangle is height times width. So what if we don't have a grid? Well, now we need to use the formula. We have to use height times width in order to work out the area. So we've got a height of 4 centimetres. We have a width of 7 centimetres. So we need to do 4 times 7. And 4 times 7 is 28. And again, the units are centimetres squared. For the next one, it's 3 millimetres by 9 millimetres. Now, just be careful here. The original units are millimetres this time, which means that in our answer, we're going to have millimetres squared. But the process is still exactly the same. It is height, which is 9, times width, which is 3, and 9 times 3 will give us 27. So next we're going to look at a different shape. We're now looking at a shape called a parallelogram. And it's called a parallelogram because it has a pair of parallel sides. Parallel and parallel and parallel and parallel. We have 2 pairs of parallel sides. Now, if you have a look at this shape, it's actually very, very similar to the rectangle we've just been looking at. Basically, all that's happened is we've tipped the rectangle over. We've just pushed it across at the top. And so actually, a parallelogram just covers exactly the same space as the rectangle would have done. And so the formula is exactly the same. It is height times width. The only thing we need to be careful of here is that when we talk about the height, we are dealing with the height which is perpendicular to the base, so at a right angle to the base. And so, for our first parallelogram, we've got our height of 3, and we're going to multiply it by the width, which is 5, and we'll get 15 centimetres squared. For the second one, again, here's our perpendicular height, 4 centimetres, so we need to do 4 times 4, and we get 16 centimetres squared. Taken away from the grid, if we were just given the shape itself, we still need to be thinking about the height, which is perpendicular to the base, in this case 2 centimetres. 2 times 6 equals 12. And finally, if we just look at the last one, this is just to show us the little trick that sometimes is played in these questions. We've been given 3 values. Now in this case, we need to be sure that we are only looking at the height and the width. And so the height is the value which is at the right angle to the base. And so in this case, it is the 10 that we are interested in. So we're going to have 10 as the height times 10, which is the base. The 12 centimetres, we don't need to know. That is just the length of one of the sides. We might use that later if we wanted to think about perimeter, but in this case, we're only dealing with area. So 10 times 10 is 100. And so the last shape we're going to look at is the trapezium. Now a trapezium includes one pair of parallel sides. And those parallel sides in a trapezium, they're actually different lengths, and that's what makes it a trapezium rather than any other shape. Now, I'm going to begin by just actually bringing this shape back in. Now, this is the same trapezium, just turned over, and I've put it together. Now, if I put those two shapes together, what I've actually formed is a parallelogram. Now, from what we've just looked at, a parallelogram needs us to find the width and the height. And so the width of this full parallelogram would actually have a total width of 8 centimetres. The height would be 2. So if I wanted to find the area of the parallelogram that I've now formed, I would have done 8 times 2. But this is not a full parallelogram. If I take away the pieces that I added in and take us back to just the original shape, the original is only half of that value. And so I need to now divide that answer by 2. The area of the trapezium would actually be 8 centimetres squared. Now, if we have a look at that, it actually leads us to a slightly more complicated formula than we've had in the last two shapes. What we have is that the area of a trapezium is a half of a plus b times h. Now, the important thing here is to understand what those letters actually mean. A is the value at the top of our trapezium. B is the bottom or the base of our trapezium. H, well, that is the height. And so we are dealing with a little bit of BIDMAS here. BIDMAS suggests we must always do brackets first. So we would have to add together the two lengths at the top and the bottom. And then this is a multiplication. It's a half times a plus b times height. Now those three values, because they're all being multiplied, we can actually do that in any order we like. That's allowed within BIDMAS. So whichever makes it the easiest calculation for you. So let's have a look at the next one. First of all, let's go and label our diagram. So the top we're going to call A. The base we're going to call B. The height we're going to call H. For our formula, it suggests that the first thing we have to do is add together the top and the bottom of our shape. And so that's going to be a half times, well, 4 plus 6 is 10, and the height is 4. A half times 10 times 4, like I say, you can do that in any order you like. A half times 10 would be 5, times 4 is 20. So we have 20 centimetres squared. The third trapezium we've got a bit more information. Now again, what we need to be dealing with here, we need to label our diagram. So the top we're going to call A, the bottom we're going to call B, and the height, again, this is the little trick. We must only be thinking about the height which is perpendicular to the base, and so H is this value here. The 5 centimetres, that is not important. Even though it is a length in the shape, it's not involved in finding the area. And so we need our formula. A half times A plus B times H. So that is a half times, well, A plus B, 1 plus 7 is 8, and times the height of 4. A half times 8 is 4, so it's 4 times 4, which equals 16 centimetres squared. Finally, we come to our exam question, and this came from the Edexcel paper in November 2017, and it was Foundation Paper 1. So this is a non-calculator paper, so we'll have to do this one all with mental mathematics. The length of a rectangle is twice as long as the width of the rectangle. The area of the rectangle is 32 centimetres squared. Draw the rectangle on the centimetre grid. Now, this is the most important thing. We've actually been told what the area is. So with it being a rectangle, we know that we have to do height times width to get the area. And so with height times width, we know we are multiplying two numbers together to get the value 32. And so the first thing we want to do is think of numbers which would multiply to make 32. Now, this is like making a list of factors. So we want pairs of numbers that will multiply to make 32. And so we'll begin with 1. 1 would multiply with 32. 2 would multiply with 16. 3, well, that wouldn't fit into 32, so it doesn't work. 4 with 8. 5 doesn't go into 32. 6 doesn't go into 32. 7 doesn't go into 32. And 8, well, 8 we already have, so we've definitely got our full list of factors. Now the next piece of information, we have to go back to the first line where it told us that the length of the rectangle is twice as long as the width. And so we need to think about the values we've just selected and which ones fit into that criteria. Well, the obvious answer is 4 and 8. And so all we're going to do is draw ourselves a rectangle which is 4 by 8. So it's going to be 8 squares along. So that's 4, 5, 6, 7, 8, and 4 down. I'll just move that into position. There we go. And so now we have a rectangle with an area of 32 centimetres squared, where one length is twice the other.